Hey, feeling good, like I should. When in dark, walk around the neighborhood, feeling blessed.
Alrighty, today's lesson, 2.1.5, is called Simplifying Algebraic Expressions, and we're going to use some of the strategies of finding and removing zeros, and we're going to continue using like KFC strategies, and we're going to bring back a strategy that was used in 7th grade to help us simplify algebraic expressions so that we can compare one expression to another. Now remember, an algebraic expression is like 2x plus 3. And if we have, say, an equal sign here, and we say that's equal to 11, we are now comparing two expressions. However, we know something about these two expressions based on this symbol in the middle. We know that they're equal to each other, so there is only one value for x that could make this expression equal to that expression. If I were to replace that equal sign with an inequality symbol, we wouldn't necessarily know what x is equal to. All we would know is that once we put in this value for x and simplify this expression, this quantity would be greater than 11. And if I turned that inequality symbol around, we would know that this value for x makes this expression less than 11, but we wouldn't know necessarily what value x is, just that it would be like less than 4, okay? So in today's lesson, we're actually not going to put a symbol in between there. What we're going to do is we're going to give you some information, and you're going to simplify each expression to the point where you can determine which expression is greater. So we're not going to say this is greater than that or this is equal to that. We're going to say here's an expression, here's an expression. You go through the simplification process and tell me which one has the greater value. Okay. So which expression, or which is greater, 58 or 62? That question might seem easy because the numbers are ready to be compared, right? We know how much 58 is. We know how much 62 is. We know that on the number line, 58 comes before 62. So 62 has to be the greater of these two numbers, correct? Okay. But however, if you are asked which is greater between 2x plus 8 minus x minus 3 or 6 plus x plus 1, you can't really tell which one is greater, or at least it's not obvious from the very beginning because we don't know the value for x and it's not been simplified. So this lesson, we are going to investigate how to compare two algebraic expressions and decide which one is greater. Okay, but to start off, let's go ahead and do a little bit of a review. You've got two expressions here. Please copy down this expression and this expression. And your task is to build these expressions on a expression map. Just go ahead and draw one like I did with a positive region on the top and a negative region on the bottom. And start off by drawing or building, if you will, 7x minus 3 on this mat, and then make some legal changes so that you can write another expression that is equivalent to this first one, okay? We're going to do the same thing here, and I'll get you started with the originals, right? This says 7x's, so I'm just going to put the 7x's in the top realm because it's a positive 7x's, right? There's nothing to say to put it in the negative region. So the 7x's would go up in the positive region, and minus 3 literally means we're taking 3 positives away from the 7x's. So we'd be taking away 3 positive ones. What I want you to do is use some legal moves to rewrite this in a different way that's equivalent to 7x minus 3. Here, this gets a little bit trickier. You see that, that 3x's there? That's in the positive region because there's a plus sign in front of them. So we could have said 3x minus, parentheses, negative 2x plus 6, or this quantity plus 3x. Either way, the 3x's go up in the numerator. That's not a numerator. Up in the positive region of our expression mat. And this is saying put this in the negative region. Put this entire quantity in the negative region. 2 negative x's and 6 positive ones. Okay? So go ahead, pause it. I'm going to go ahead and build another one, and then go ahead and rewrite the expression that goes with your new, um, what are we calling this? Your new tile representation of the expression. Do that for here, do that for here, and then rewrite each new expression. Alrighty, now I want you to keep this in mind. You might have a different answer than I have. There are a number of different ways that you could change this expression and have it be equivalent to the original. I just went with the one that seemed most obvious to me. So if there's any questions at all, do not hesitate to contact me. Email, ask me. You can send a picture of it on your phone and email it to me. Say, hey, is this okay for problem 46A or 46B? And I'll get right back to you as soon as I can. So first off, I'm noticing, what if I decided not to have these guys down here in the negative region? What if I decided instead to move them across the street? That process, called KFC, instead of saying 7x minus 3, you could say 7x plus a negative 3. And it goes in both directions at KFC. So this would be another way to write this expression. They mean the exact same thing. Notice when these guys cross over, they change their opposites. Here, I did the exact same thing. You've got your two negative x's there. That just seems a little bit odd to say like 3x's minus 2 negative x's. So I decided, what if I move these two guys across the street, but maybe keep them the same? So I end up with 5x's on the right. I'm not on the right, but in the positive region. And then I just left these down here because, you could just leave those there if you wanted to. So basically what we've got here is you got your 2x's that add with the 3 positive x's that were already up there to make a total of 5 x's on the top. Okay, so both of these moves of moving things across the street, that fits in with what we learned about adding the opposite, the whole KFC process that we learned in 7th grade. All right, so now we're going to get to expression comparison maths, where we're going to take a mat on the left and a mat on the right, and you need to figure out, okay, what is the expression that this represents? For instance, this one has 3 negatives in the positive values, so that has a value of negative 3. This expression has 2 positives, but they're in the negative section. This is like saying the opposite of positive 2, which is also called negative 2. So if we were to determine which side is greater, now you have to think about these 2 numbers on the number line. Which one is farther to the right on the number line? Turns out negative 2 is farther to the right than negative 3. So negative 2 is greater than negative 3. So we could just kind of draw a circle around here and say negative 2 has the greater value. So the mat on the right is the greater expression. That's wonderful when all you have are unit tiles. But as soon as we start introducing variables into these expressions, now it's going to start to get a little bit more complicated. So what we're going to do is, and I believe you can access this from the online. Let me see if that's the one right there. That was problem number 49. Can we do this on 47? Yes, problem number 47. These are already provided for you with the online tool. So you don't necessarily have to build everything, although it would be good for you to draw this into your journal to record everything, but you can use this to help you with the process. Okay, I'm going to use my technique here because I can write on this page. So you've got yours over on the online page. I'm going to use this one here, but I'm going to record what we got. So to start off, what do we have in the positive region being added together? You've got an x, a 2, and a negative 2. So x plus 2 plus negative 2. And what's being subtracted away? 3 positive 1s. So x plus 2 plus negative 2 minus 3 is this expression that is represented here. And on the right side, you got an x plus a 2 plus a negative 3 in the positive region. And what is being subtracted away are 2 negatives, so minus a negative 2. So we're going to use some legal moves here And I typically, I am just a big fan of starting off by getting everything up into the positive region. You don't necessarily have to do it that way. We could remove these 0 pairs if we wanted to, but that's not really how it goes down here. Although, actually, we could possibly do that. Maybe we can go ahead and do that. Let's go ahead and take away, here's a 0 pair that we can make go away. And I'll just bring them down to here. Here's a 0 pair that we can make go away. And if you're using the online tool, then what you can do is this. You can just highlight all of them and hit the delete button, and they go away. Let me see if I can do a Control-Z and bring them back. No, there's no bringing them back with the Control-Z. But that was fine. That was our goal. Okay, and on the right side, do we want to remove some zeros here? Those look like 2 0 pairs that can go away. And it looks like this is a 0 pair that can go away. Because remember, they're either opposites in the same region or the same tile in opposite regions. So let's go to the online tool and do the exact same thing. We got those 0 pairs that went away, and then we've got these 0 pairs that went away. So you've got the same thing on your online tool as I have in my program. Okay, so let's rewrite this. After removing zeros, we now have an expression that says you got 1x, and then you're taking away 3 positive 1s, x minus 3. And on the right side, you've got your 1 positive x, but now you're taking away a negative 1. Now, I would rather not write it this way. I would rather actually now move this guy across the street and change it to its opposite. And you can do that with the online tool by just moving this across the street and clicking on it, and it'll change to its opposite. So now we can rewrite this expression on the right side because we've just done K, F, C. We can rewrite this guy as x plus 1. So if you got x minus 3 and you're going to compare that to x plus 1, can you tell which one is greater just looking at this? Keeping in mind, the x's have to have the same value. If they didn't have the same value, we'd call one of them x and one of them y. So some amount, take away 3 from it, how does that compare to that same amount adding 1? Well, it seems pretty obvious that this amount has to be, oh no, did I just make a mistake? This has to be less than that, so the alligator always eats the bigger lunch, right? So the one on the left has to be less than the one on the right. Now, what you may recall from last year is, could we do this? Is it legal to take away an x from each side? Remember, we called that last year, if this was removing zeros up here, we called this removing the balanced sets, which I called removing the BS, right? Take away the x from the left side if you can take one from the right side, and that leaves you with a negative 3 and a positive 1, and now you can absolutely compare them without having to think in the abstract about the fact that x's are the same in both 1. So now you just have the numbers, you know negative 3 is to the left of 1 on the number line, so this has to be less than that, and the 1 has to be greater than the negative 3. Okay? All right, so now we've got some notations. Let me read through this. As Carl simplified some algebraic expressions, he recorded his work on the diagrams below. See, he's drawing a picture in his journal, and he doesn't have the luxury of using the tool that I use to manipulate his pieces around or using the online tool. Let me actually look at this and see, do we have one for problem number for Carl? Do we have one of those online tools? We don't. So there are some notations that he has chosen to use. Okay, so take a look. This is what he started with. And then after doing the notations here, this is what he ends up with. What is that he's circling there? What is happening? You see that he's circled this 0 pair, this 0 pair, this 0 pair, and on the right mat, he circled this 0 pair. And after circling those, what happens to those 0 pairs? They go away, correct? This is what we refer to as removing zero pairs. So you can use this when you're drawing your diagrams, like we have over here. I could have had us look at it this way and say, okay, let's circle this zero pair, let's circle this zero pair, let's circle this zero pair, this zero pair, and this zero pair. So you're left with x minus 3 and x minus a negative 1, just like what we had over here before we did the KFC. Okay, so you can do those types of notations in your journal to help you see that those are going to go away, and you're going to be left with this. Now that we've cleared out all those zeros, can you determine which one is greater? This has a value of positive 1, and this has a value of negative 2. So can we all agree that the left side here, positive 1, has to be greater than negative 2? Yes, it is. Now let's take a look at what Carl is doing with this move. This is where he had negative 1 minus a negative 2, like we see here, and then he moves these guys across the street so that they change to their opposites once they've been moved across the street. This process is what we refer to as KFC. You're adding the opposite. So instead of subtracting negatives, we'll move these guys into the positive region so they're being added to each other. And then from this point, you can identify your zero pairs. And this ends up making 0 out, they 0 out. This ends up being a 1. This ends up being a negative 1. So which side is greater? The left side, 1, is greater than the right side, which is negative 1. Okay? So 2 legal moves. This one, actually, we used both of them, right? We started by getting this guy across the street to make it easier to find your zeros, and it's always easier when you're adding numbers than when you're subtracting them. Okay? And now for the last bit. This, you've got balanced sets on either side. So remove the balanced sets, and then we can go through the process. In fact, we could remove some more, right? I mean, he didn't remove them all. It looks like you can take away these 3 as well. So you've got nothing left on the left-hand side. And after everything has been like that's been removed, it's all been taken away, all you have left is the one over here. If you wanted to think about it this way, you could say, well, there's a zero pair, that's going to go away. There's a zero pair, that's going to go away. And then this is, those are balanced sets. So either way, we're going to see at this point, the right side, oh, this is getting kind of sloppy. The right side is going to be greater than the left side. Okay, so these 3 moves, the removing of zeros, the adding of opposites, or doing KFC to make it easier to manipulate the terms in your expressions, and then the removal of balanced sets. This makes up the foundation of how we solve algebraic equations and simplify the respective expressions on either side of the equation. And it doesn't just work with equations now. You're seeing it also works with inequalities, right? We could turn this into an inequality because we know which side is greater in each one of these instances. All right, so this is going to ask us now to use these legal moves, and I guess maybe I should. For this lesson, I'll make sure to have this resource page on class. What is it called? Classroom, Google Classroom, so that you can download it, you can print it, and have it in front of you, so you can do this recording. Some of you I know maybe don't have a working printer, so in that situation, you do just kind of have to draw these out. Just pause the video and take the time to draw them out. It's not going to take you too much time. It might even take longer to find that resource page and print it than it would to just draw them out. So whatever works for you. But I'll be sure to include this resource page on Classroom when for you, and you would have already seen it because you're already watching the video. Okay, so use our legal moves and do the recordings. I guess you could do the striking out, or this particular problem does have the student tools that you can use if you want to use this instead of making the notations on your worksheet. Okay, so let's start off by writing down each one of these expressions. In the positive region, you got 1, 2, 3, 4, 5 positive ones plus 3 negative ones. So 5 plus negative 3. Then you're going to take away the positive one and you're going to take away the negative 2. On the right expression, Matt, you've got 1, 2, 3 positives and 2 negatives being added together. And then you're going to take away a 1 and take away a negative 3. So where do you want to begin? Do you want to start by moving everything across to the top so that we can do KFC? Or do you want to start by removing as many zeros as you can find? Let's go ahead and start with removing zeros. I'm going to call this RZ, okay? And so if you remove the zeros here, there's a 0 pair, here's a 0 pair, here's a 0 pair, and technically this guy zeroes out with that guy, leaving you with just minus a negative 2. So I'll go ahead and rewrite this as minus a negative 2, right? This is the one thing about using the expression maps. It doesn't really make sense to me looking at this expression how we get from here to here. But using the expression mat, that's precisely what we did simply by removing zeros. Seems to me, I'm going to just do it a different way here. I would start by, let's just call this 2, right? We'll remove our zeros there, minus 1 plus 2. And so this ends up becoming 2 plus 1, which is, no, this isn't right. Where have I made my mistake? I'm going to pause for a second. I think I might have made a mistake here. Okay, I found it. See that little guy right in there? I forgot that person existed, or that tile existed. So let's go back and rewrite this as 1, right? You would have had 1 there, minus a negative 2, which would eventually give us a positive answer of 3 for this mat by the time we move things across. Let's just leave it like this. Yeah, let's just leave it like this. And on the right-hand side, what do we have going on here? We've got a 0 pair here. We've got a 0 pair here. We've got a 0 pair here. And then that leaves us with, on the right side, a 1 minus a negative 2. Okay, now let's picture moving these guys across the street. I'm going to use a different color for this one. If this guy moves across the street and this guy moves across the street, that's like us doing KFC here, correct? So that's our next move, is doing KFC. And this is going to become 1 plus 2, which is equal to 3. And on this side, it's going to become 1 plus 2, which is going to be equal to 3. And what do we know about these two expressions when all are said and done? Let me go ahead and move this guy across and move that guy across just the same. We end up with 2 expressions that we know are equal to each other. Okay? Okay, let's do the next one. Or do you need me to pause? Well, let me see if you can do this one on your own. So I'll pause it. You see what you can do with this and see if you get the same answer as me. All right, so what do we have on here? We've got, I like to start with the variables first. Once again, I always start with the expression of the area up in the positive region. So we got x plus 4 plus a negative 2 minus a 2 minus the negative 1. Now, I think I'm going to do things a little bit differently this time. I'm going to start by doing KFC to begin with. I really like moving guys across the street before I start removing zeros. For me, that's kind of the order in which it happens when we're simplifying the expression without the algebra tiles. So let's start doing it in that order. And here we have your x plus your 1 plus your negative 2 minus your negative 4. So if I start off with KFC, that is us moving these guys across the street. And when you do that, they become their opposites. So that becomes a negative, that becomes a negative, and this guy becomes a shaded and positive. Okay, so they're no longer there. And on this side, all four of these guys move across the street, and they become 1, 2, 3, 4 positives. Okay, so let me show how that would work here. I'm going to move this guy across the street, change it to its opposite. I'm going to move these guys across the street and change them to their opposites. And that's like me doing this. The X stayed where it lived. The 4 stayed where it lived. The the -2 stayed up there, but now I'm going to change that to adding a -2. And I'm going to change that to adding a +1, right? This guy moved across the street, became a +1. These two moved across the street, became 2 negatives. Now let's do the same thing here. These 4 are going to move across the street. So the X likes where it lives, it's going to stay there. The 1 likes where it lives, it's going to stay there. These guys like where they live, they're going to stay there. But these guys are going to move across the street, and they're going to become +4 instead of the opposite of -4, like what we see right there. And I'll put them together a little bit, move them across the street, and change them to their opposites. And now we're ready to remove zeros. So removing the zeros, here's a 0 pair, remove them. Here's a 0 pair, let's remove them. Here's a 0 pair, let's remove them. And here is a 0 pair, let's remove them. Leaving you with just X plus 1. Oh, I don't want the color. Leaving you with X, right? That X didn't have anything else to combine with. Notice how this 4 and that makes -4, and those all combine are going to make the 0 pair that we see here. So then we're just left with X plus 1 on the left-hand side. What do we have on the right-hand side? We've got a 0 pair here. That's going to go away. And we've got a 0 pair here. That is going to go away. And so when all is said and done here, we've got X plus 3. Let's see if we can find that X plus 3 here. You got 1 plus a -2, which is -1, and -1 plus 4 gives us your 3, so your X plus 3. So I feel like that, doing it in that order makes so much more sense for how you would actually show your work when you're simplifying the expressions. Now, can we remove balanced sets? Yes, we can. Do you already know which side is greater? Yes, you probably do. A number plus 1 has to be less than the same number plus 3, doesn't it? So doesn't that mean that the right side has to be greater than the left side? Yeah, it does. But let's go ahead and now let's remove balanced sets. Removing the balanced sets means we're going to take away the same amount from each side. I'm going to take away an X from each side, and I'm going to take away a 1 from each side. When we do that, we're left with, let's see, let me just go ahead and show taking away the X from each side and the 1 from each side, take away an X from each side and a 1, right? Balanced sets we're removing. And what do we have when all is said and done? We're left with nothing on this side and 2 on this side. So 0 is less than 2, which makes the right side greater. Okay? So this process, we're going to leave the tile figures behind after a while, and you're just going to be responsible for doing this. But we want you to fully understand how this works and why it works. And the visuals, these concrete manipulations that we're doing, manipulatives, whatever, I'm getting tired. These are a way for it to embed in your thinking. If you can picture what we're doing here as you're solving these problems, it's going to make more sense. And these right here, the 3 steps, the KFC, the removing zeros, and the removal of balanced sets, are pretty much the same steps that you do every single time when you're simplifying expressions. The KFC just removes the subtraction problems, allowing you to use commutative property, which allows you to move the terms around, cluster them together to make it easier to solve the problem. The removal of zeros is what happens when you're combining like terms and you're adding a positive to a negative. When you're just adding like positives together, there's no zeros to remove. You just take the 1 and the 4, you put them together to make 5. But as soon as you want to add 5 to -2, then the removal of zeros comes into play. And then the removal of balanced sets, whenever you do to one side of an equation or inequality, do the same thing to the other side, and everything stays balanced. Okay? So that does it for today's lesson. Once again, go do your homework, show all of your work, record everything, and then if you make mistakes, correct those mistakes. All right, take care. Bye.
Hey, feeling good, like I should.